The European Union's AI Act isn't just another set of rules for tech developers. No, it's something much more profound. It's a complete restructuring of the AI world as we know it. It takes what was once a simple technical supply chain, from the big foundational model all the way to the final app, and forges it into a legally binding chain of responsibility. So let's explore exactly how this new legal architecture works. Here's the map for our journey today. First, we'll look at the new chain of responsibility and meet the key players. Then, we'll unpack the two-tiered rulebook they all have to follow. After that, we'll dive into some of the toughest liability challenges. And finally, we'll see how transparency is the key to enforcing this whole system. And this is really the core idea you need to grasp. Every time an AI component is passed from one company to another, it's no longer just a technical handoff. It is now a legal event, a transfer of very specific duties and, crucially, potential liabilities. Understanding this shift is everything. All right, so let's meet the main characters in this new legal landscape. The Act defines very specific roles. It calls them operators, and these operators form the links in this chain. Each one has a distinct and mandatory set of obligations. Everything begins upstream with the GPAI model provider. Think of them as the ones who create the foundational technology, like a massive language model. Now, a key principle here is that liability follows the brand. The company that puts its name on that model and puts it out on the market is the one on the hook, legally speaking. It doesn't matter if they hired someone else to actually build it. So let's follow the chain. Next up is the downstream provider. This is the company that takes that general-purpose model and builds it into a specific product for a specific purpose, say a tool for diagnosing diseases or a system for credit scoring. And it's really important to note that one company can actually wear both of these hats. If a big tech firm builds its own foundational model and uses it to power a high-risk product, well, they have to follow the rules for both roles. The final link in our chain is the deployer. This could be a hospital, a bank, an HR department, really any organization that actually uses the finished AI system in its work. Their legal responsibilities aren't about the system's design. They're focused on using it safely and correctly, just as the provider instructed. But this is exactly where things can get very, very tricky. You see, there's a razor-thin line between just using an AI system and actually changing it. And if you cross that line, you can trigger a massive shift in legal responsibility. It's something we can think of as a liability trap. This is all laid out in Article 25 of the Act, and honestly, it's a bombshell. Let's say a bank, a deployer, takes a high-risk AI system and makes what the law calls a substantial modification. Maybe they fine-tune the model on their own private customer data. In that instant, they are no longer considered just a user. They are legally reclassified as a provider, and they inherit the entire, and I mean crushing, compliance burden that originally belonged to the developer. Okay, so now that we know who the players are, let's take a look at the rules they're playing by. The Act effectively creates two different but deeply connected sets of rules that flow down this chain of responsibility. So you have these two rulebooks working in parallel. On one hand, you've got Title III, which has these really intensive rules for specific, high-risk applications. Think about that medical diagnostic tool again. The whole life cycle is regulated, from the first line of code to its use in a hospital. On the other hand, there's Title V. This is a newer set of rules aimed just at the foundational models themselves, and it's much more focused on transparency and documentation at the source. And for those high-risk systems, this slide shows the handoff of responsibility perfectly. The provider does all the heavy lifting up front. They have to design for safety, document absolutely everything, and prove the system meets the rules before it can ever be sold. The deployer's job, then, is to take that system, use it exactly as instructed, and keep an eye on it in the real world. It's a very clear division of labor. Now, what about those foundational models? The Act sets a baseline of duties for every single provider, big or small. They have to keep detailed technical documentation for regulators to see. They have to respect EU copyright law. They need to publish a summary of what's in their training data. And this one is absolutely crucial. They must provide a detailed instruction manual to any company that builds on top of their model. And the law is crystal clear about why this information flow matters so much. This documentation, which is detailed in a section called Annex 12, acts as a legal bridge connecting the upstream model creators with the downstream application builders.
Its whole purpose is to give that downstream provider all the information they need to understand the model's limits and, in turn, build their own compliant and safe system. This is without a doubt the most critical link in the entire value chain. But what about the really, really powerful models? The Act draws a line in the sand. 10 to the power of 25 floating point operations. That's the computational power used to train the model. If a model is trained with more than that, it is automatically presumed to pose a systemic risk. This is the Act's way of grappling with a huge question. How do you even begin to regulate a technology as it gets closer and closer to something like AGI? Crossing this line triggers a whole new set of much, much stricter rules, like mandatory stress testing and reporting every serious incident. Now, creating this new chain of responsibility is bound to create some new and complex legal challenges. So let's explore what happens when things go wrong, and more importantly, who is ultimately held accountable. To really get liability, you have to see how two different laws work together. First, you have the AI Act. Think of it as the rule book that's designed to prevent harm from happening in the first place. But it doesn't actually give a victim the right to sue. That's the job of the second law, the Product Liability Directive, or PLD. The PLD is the lawsuit. It's the tool for getting compensation after the harm has already been done. So here's where the rubber meets the road. The revised PLD makes it clear. AI systems are products, and the GPAI models inside them are components. What this means is that if an upstream provider fails to follow the AI Act's rules, let's say they leave out a critical warning about their model's blind spots, that failure can be used as direct evidence in a lawsuit that their model was a legally defective component. The rulebook, in effect, becomes the foundation for the lawsuit. But real-world systems are messy, right? A single bad decision, like denying a loan, might involve several different AI models all working together. So if something goes wrong, who's to blame? Was it the model that summarized the application, the one that calculated the risk score, the one that put it all together? The only way to untangle that knot is through meticulous logging. The Act says providers must build systems that can create these logs, and deployers must use them. They are the black box recorder, the only piece of evidence that can trace a failure back to its root cause. Now, there's a big question mark around open source models. The AI Act seems to offer them an exemption, to help foster innovation. But is it a real get-out-of-jail-free card, or is it more of a high-stakes gamble for developers? Well, the reality is, this exemption is incredibly narrow. It only lets you off the hook for a couple of documentation rules. And here's the kicker. It does not apply to any model deemed to have systemic risk. This creates a huge potential problem. A developer could release a powerful open-source model thinking they're in the clear. But if that model becomes really popular and regulators decide it's now systemic, that exemption disappears overnight. And just like that, the developers are in massive breach of the law's toughest rules. So with all these complex rules and roles, how is the EU actually going to enforce this? Well, the entire system is built on one simple but powerful idea: transparency and traceability. This is how that paper trail for accountability is built. The upstream GPI provider creates their documentation for the model. The downstream system provider then takes that information and uses it to complete their own technical file for their final product. This creates a perfect, unbroken chain of documents. It allows a regulator to pick up a faulty end product and trace the responsibility all the way back up the chain, link by link, to the original foundational model. And that brings us right back to where we started. By forcing this flow of information and creating this clear paper trail, the EU AI Act achieves its main objective. It systematically transforms what was just a series of technical handoffs into a seamless, legally enforceable chain of liability where everyone has a clearly assigned responsibility at every single step. This new legal reality is going to affect anyone who builds, sells, or even just uses AI inside the European Union. And it forces all of us to ask a pretty fundamental question. In this new legal chain of liability, where is your link? And are you truly prepared for the responsibilities that now come with it?